Hello and welcome to demola, and today's lesson we're going over Hess's law. Finally, we're at the end of equilibrium. Should be a good time. Let's get straight into it.
Okay, let's talk Hess's law. So, Hess's law is defined as the total enthalpy change being independent from the route taken. What do you mean by that? Well, have a look at this reaction here. You see, we're going from A and B to C and D. But if we look at 2, there's a separate pathway where we go from A and B, we go to form E and F, and then we form C and D. What we're saying is that either this direct route, so we'll do on top the direct route here, or we have an indirect route here. What we're saying is both of them have the exact same enthalpy. So the enthalpy change reaction of 1 is the same as enthalpy change reaction 2. We use Hess's law when we want to determine the enthalpy change of a reaction that we can't do experimentally. So we've already done a video that's described calorimetry. That's your experimental methods to find the enthalpy change. But we use Hess's law when that's not possible. Why might that not be possible? Well, I will say your big 2 are going to be these ones in the bracket that I've highlighted. Activation energy being too high, rate of reaction being too slow. Those are the ones that you're going to want to say the most in the exam. If you're really stretching, reaction doesn't occur or can't be done experimentally, would be another reason why we might use Hess's law. But really, what we're trying to say is activation energy too high, rate of reaction is too slow. So, when we're doing Hess's law calculations, which we're going to get into in a second, you'll either be given enthalpy change of formation data, or you'll be given enthalpy change of combustion data. So I just want to stress this right now. It's so pivotal that you look at what they're giving you on the table, because it will determine how you work out the question. It's about to be a bit long-winded, but we're going to get into it. So, Hess's law when we have formation data. Well, this question is calculating enthalpy change combustion of hexane. Yeah? And they've given you the data in the table. We can check formation data. Cool. So your first step is going to be write out the equation, and I've balanced it there. So combustion of hexane, you've written hexane, C6H14, added oxygen, we're forming carbon dioxide and water. We just need to balance it. Cool, that's step 1. Step 2 is we need to look at the data given in the table, which we said was formation data, and we need to sub it in, or we need to draw the arrows. Let's talk about this. So I showed you in the diagram before, if we just focus on the black arrows for now, I showed you in the diagram before that we have the direct reaction, which is the one up top, and we have the indirect reaction where we have to go to the elements first. Now, I've just written elements instead of actually writing out the products, just because they typically will never ask you to do that. So I think don't bother yourself trying to stress out on it. Now, I was told with formation data, a way to remember why the arrows are moving on the inside is that you're building up. So the arrows are both going up when you're working with formation data. Yeah? These are the blue arrows on the inside I'm talking about. It's going to help us calculate. Now, what we need to think about is this arrow here, I'm going to circle in red. That arrow is not going the way that we want it to. Yeah, it's not going the way we want it to. So, we're going to make everything on that side negative. Whilst on the other side, this arrow is going in the direction that we want it to. So we're going to say plus. And formation, building up. So, now we've established that, I can sub in the values, right? So we have, from the table, the enthalpy change of, there's enthalpy change of combustion. Enthalpy change of formation. Enthalpy change of formation of hexane is minus 199. Oxygen does not have an enthalpy change of formation. Carbon dioxide and water were given here. And now, like we said, we're reversing this side that I've just put the line next to. So we're going to do products take reactants. So products on the right, the side that we're keeping positive. Reactants, the side on the left that we're making negative. And you only sub in the values, you should get minus 4,161 kilojoules per mole. Any questions about that, make sure to ask it below if you need to read the question. But really, the pivotal part of this question is being able to draw these arrows on the inside so that we know what side we need to reverse, which one we need to keep going. Okay, we can probably afford to be a bit quicker with this example, but now we're finding the enthalpy change formation of ammonia using the reaction given. You can see the reaction given below, N2 plus 3H2 goes to 2NH3 gas. Now, the reason I've highlighted that positive 180 in the table is because I've told you in the past that all of the enthalpy change of combustion data should be negative. So when I see positive 180, I'm a bit confused. I did a bit of research into it, and it's because of how strong this triple bond is in nitrogen. So nitrogen normally exists with a triple bond. This is very, very difficult to break, which is why you're going to get more endothermic, more endothermic, more endothermic. When you make the bonds for the combustion products, then it's exothermic, or that process is releasing energy. But overall, because of how strong this bond is here, it's going to be an endothermic. Cool. So we do something similar. We're going to draw on the arrows, right? Now, combustion, break down when you're combusting. So that is going to help us to know where the arrows need to go. Now, we've got a different thing where this is facing the right way, but this is now facing the wrong way. Yeah? So when we're subbing in the values in the next step, what you need to think of is this side needs to be reversed. This side needs to stay positive. So we'll literally do that. So you can see that's for nitrogen, the 180. For the hydrogen, that's a 286, the minus 286, times it by the 3 as well to keep it balanced. And then the minus 293 times 2. Again, we're just keeping things balanced. So once you've done that, you'll realize it's reactants minus products this time. Put in your values. Now, the last thing that I need to say is, why did we divide by 2 at the end? Well, the question told us, find the enthalpy change of formation, right? And what's the definition of enthalpy change of formation? Well, it's going to be that you're producing 1 mole of the substance, yeah? That's really, enthalpy change when 1 mole of the substance is produced from its elements. That is the definition. So because we're only making 1 mole, but in this question we had 2, you need to divide it by 2 at the end. Okay, we're proper whizzing through this, but we have some questions for you to try. I'm going to zoom into them one at a time. So you've got this first one. We need to write out a couple of equations and then calculate enthalpy change of formation. And this other one, you need to find the enthalpy change of combustion, I believe. Yeah? Exactly. So I'm going to leave you to it. You can see both on the screen now. Pause if you need to, and we'll get into the answer. Okay, it's answer time. So first one, we're just doing combustion of this product. I think it's called ethylene. Not too complicated if you know what you're doing. And then same with the formation for part B. Again, shouldn't be too complicated. And state symbols is pivotal. Cool. So when we get to part C, we need to think what's in the table, right? You have formation data in the table. You can see it here. It's formation data. So our arrows on the inside are both going to go up, which means we're going to do products minus reactants. Yeah. So some of my values, I get ready to do products minus reactants. Essentially, it's algebra. So I'd say just take a minute, look at my workings out. Pause if you need to, but it literally is kind of just like algebra if you do maths. Now, number 2, they said the enthalpy change combustion of heptane. No, it's not heptane, pentane. Yeah. You can see the arrow on the right is going the wrong way. So we're going to do reactants take products. So I have already done that in terms of the 6171, the minus 6171. And then we need to add on the one from ethylene and the one from pentane. Yeah? So you do that. 2 times minus 1411 plus x. And you keep on going and going and going until you finally get x is minus 3535 kilojoules per mole. I hope that makes sense. Okay, and that's been an overview on Hess's law. Now we finish off with the A-star tip. So what's been useful? Well, I think what's really useful to make sure you can understand by the end of this week is what Hess's law is, why is it relevant, be able to construct that enthalpy cycle like the one I was showing you where the combustion hours go down, the formation go up. These are going to be really, really important throughout your exams. So it's very, very good to get them known and locked in right now. Also, I think calculations were done really well today overall. I think calculations were done really well. And I did like that there was a couple of people in the room that seemed to be quite confident in terms of just kind of going for an answer that they have instead of kind of waiting around. Finally, what not to do. Well, I think a lot of the equations you're going to get might be unfamiliar or a bit complicated. Don't get thrown off. Stick to the bases. Know those reasons why we can't use Hess's law, because if it comes up as a 1-2 marker in your exam, you're going to regret not being able to get it. Yeah, that could be the difference between grade boundaries. So make sure you aren't the one that falls for that trap. And then also, you just need to use what's actually in the question. That's the wrong way. You're using what's in the question over your own knowledge. I feel like even in UCAT they kind of reinforce that idea. But use what you've seen, not the knowledge of others. So, finally, we're at the end of the lesson. I hope I haven't waffled too much. I'm getting a bit tired. But thank you so much for listening. Any questions at all, and I mean at all, drop them in the comments below. I'll do my best to answer very quickly. If you enjoyed the video, please like, subscribe. Really, really do support it. Helps a massive load to keep you motivated. We've got the TikTok and the Instagram, both at ASR Demola. But that's all for me now, and I'll catch you in the next one. Bye!